Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we will discuss question number 40, NEET Physics paper 2015. Hello students, let us solve question number 40. The question is, figure below shows two paths that may be taken by a gas to go from state A to state C. This is one state, this is the final state. The gas has to undergo either directly from A to C or by following this path A, B and C. So this is suppose path 1 and this is suppose path 2. So it just go like that. Now in process AB, this one, 400 joule of heat is added to the system and 100 joule of heat is added to the system in the process BC. So here 400 and here 100. So total 500 heat is added to the system. The heat absorbed by the system in the process A to C. So from here to here, how much heat is absorbed? That is the question. So obviously, if it is 400 here and 100 here, so total is 500 in this part. We cannot say that it is from A to C, it is also 500. So this option is not right because heat is not a state function, it is a path function. So as you change your path, the heat also will change. So obviously we have to find that. And our aim is to find in the process A to C what is the heat absorbed. That means we are asked to find QAC. That is the question. So first let me draw the diagram. This is the pressure axis and this is the volume axis. Here the volume is in meter cube. This is in meter cube and the pressure is in Pascal in it as a system. There exists a path from like this here to here. This point is A, this point is B and this point is C. That is the three states. Suppose this is 1 and this is 2 and this goes like that. At A the pressure and volumes are given. At A the pressure and volumes are given. This is 2 10 to the power minus 3. Here it is 2 10 to the power 4. Units are given. At B the volume remains the same but the pressure is 6 10 to the power 4. And here at C the pressure is that and the volume changes to 4 10 to the power minus 3. Now if I want to apply for first law of thermodynamics, if I apply first law of thermodynamics, I know that the amount of heat that I am supplying is used up in increasing the internal energy of the system plus the external work done. This is the first law. Now if I want to apply first law, and because we are comparing path 1 with path 2, but the state we have to, this is the initial state and this is the final state, because the state is same, so irrespective of whichever path you follow, the change in internal energy in both the cases will be 0. That means this will not contribute. The change is internal energy in a cyclic process is 0. So here is independent, so that will be in the cyclic process it will be 0. It is not 0 if I follow this or if I follow this. In a cyclic process it will be 0. So this is 0 in cyclic process. Individually if I go from ABC or AC, it is not 0 because there are different states. Different state means different temperatures, so there is a change in internal energy. But if I consider ABCA, for example, ABCA, then obviously it is 0. Now, so in a cyclic process, the heat, total heat in a cyclic process is equal to the total work done, because in a cyclic process delta U is 0. Now delta Q, I consider the path A, B, C, A. I consider the cyclic process A, B, C, A, then AB, BC, CA, then I write heat from AB plus heat supplied in BC, AB, BC, and then CA. The sum of all the heat content must equal to work done in cyclic process. This is the work done in the path ABCA, which is the area under enclosed loop. This is equal to the area under the enclosed loop. That means in a cyclic process, whatever area is this one, that is the work done during this process. So what is this area? This is a right angle triangle, and the area is half of base into height. So this will be, so I'll write that this area is half of base. This one is the base AB, and AB is this distance, which is 6 minus 4, that is 6 minus 2, that is 4, 10 to the power 4. So it is 4, 10 to the power 4. Base is there. And what is the height? This is the height. This height is this distance. And this is 4 minus 2, that is 2, 2 to the power. So 2, 10 to the power minus 3. So this is the work done during this process. Okay. So this is the work done, and the heat supplied from A to B is given as 400 joule. So it will be 400 plus, this is BC, which is given as 100, plus QCA is this one. So from here, this is our equation from where I can get QCA. So this implies that here let me just calculate that this is 500 plus QCA equals to, these two will cancel, and this is 40. This is actually 10. This will cancel 10 and 40. This is 40. So from here, QCA is 40 minus 500. So this is minus 460 joule. QCA is CA during this process minus 460, means it is not absorbed, it is delivered, is given out. But what is asked is the heat absorbed by the process from A to C. C to A we have got, but A to C heat is absorbed. A to C is absorbed. From here to here it is giving out 460 minus, because it's giving out minus. From A to C it will be the same amount but plus 460 joule. Okay, so therefore QCA is negative but AC is positive, so it is 460 joule. So if you see the option, then 460 joule, it is the first option which is correct. Okay, thank you.